Really appreciate everyone putting in their time to come and join us on these webinars. Today I'm joined by Michael Friedrich, sorry, CSA from Microsoft, who's going to talk to us about how compliance and image control within the Azure platform is obviously an important part of that image and image control and workflows. And then I will be talking about how Packer can add value to that and where it fits into that lifecycle journey. So with that, and with everybody, hopefully, the recording of this will be sent out after we finished, usually within 48 hours or a couple of business days. Anyone who's registered will get a copy of this, and we will be having a Q&A session towards the end. So if you do have questions, please save them for the end, and then we can have a Q&A session or answer those in the Q&As. Anything that goes in, if you could use the question and answer or Q&A tab rather than the chat, just so that we can record them and make sure that anything that cannot be answered or any questions that we can't get to, we can make sure that we can answer them offline. With that said, I will hand it over to Michael to start. Thank you.
Perfect. Thank you, David. Go to the next slide, please. Cool. Fantastic. So why are we here? Why are we talking to you guys today? So there's kind of 4 key things I want to cover off here. The first one is each enterprise has its own compliance regulations and standards. So whether you're in the financial services industry and you have industry regulators to work with, or in the public sector and you have government regulations to adhere to, you need to understand the technical compliance regulations and standards you need to meet in the cloud. Second one here is regarding security, each company has their own risk appetite. So hopefully your company has a high appetite for that, but engage your leaders and your CISO to see what enterprise standards your organizations need to have. For example, do you have different standards for externally facing applications versus internally facing applications? Or are you looking to create a security baseline across your whole VM fleet and all of your applications running in the cloud? The next one is fairly obvious, but I do want to cover it off. So following different standards can be more challenging in dynamically scaling cloud environments than it is on premises. I know this is fairly obvious, but it's important to acknowledge this. In the cloud, you might have many more teams with the ability to spin up VMs than you ever did on premises. For example, you might have your DevOps teams, your platform teams, your developers, your product teams, all able to spin up virtual machines in different environments all over the shop in your Azure cloud environment. So how do we make sure that our VMs are adhering to the standards that our enterprise has set up? And finally, by using Azure policy and role-based access control assignments, enterprises can enforce standards on Azure resources, but the system images still pose a security threat on Azure. What we mean by this is that Azure policy and role-based access control assignments can normally control and enforce standards across what we call the control plane, so things around the virtual machine, but it can't reach in and change things inside of the operating system or the system image. So what we want to do here is we do want our teams to be productive in the cloud, but also minimize the security threat on the virtual machine or the operating system inside of that virtual machine. So absolutely, you must be using Azure policy and hardback assignments, but we need to do more with the system images to reduce that risk. Next slide, please, David. Cool, so we've got some potential use cases here that we want to talk through in today's session. So the first one is supplying golden image to our DevOps or platform teams. I'll go through what a golden image is in a moment. Second one here is testing and validating images before making them available to this DevOps or platform team. Next, we want to do also is track which images each team is using, enforce company standards without degrading performance. And we also want to make sure that our DevOps and platform teams and potentially developer teams, if you allow them to spin up virtual machines in the cloud, are using the latest image versions. And then lastly, we want to make sure we're managing the compliance of pet servers, which are maintenance intensive, and cattle servers, which are easily replaceable. And we'll go through in the next couple of sections what a pet server is and what a cattle server is. Next slide, please, David. Cool. So 2 solutions that we want to talk through here. The first one is the golden image publishing process and how we do that end-to-end inside of Azure, and the process of tracking virtual machine compliance with Azure policy. Cool. Next slide, please, David. Cool. So I've mentioned this wording a couple of times now. So I want to go through what exactly a golden image is. So a golden image is an image on top of which developers can build applications, letting them focus on the application instead of system dependencies and patches. So typically you want your DevOps team or your platform team or team that's maintaining your Azure cloud environment to build these golden images, so developers don't have to worry about system dependencies and patches and your customizations, and they can instead focus on building the application. So each enterprise has their own compliance regulations and standards that you need to meet inside a VM. A golden image is a way for you to manage the image of a virtual machine that has all of your customizations already built in. So whenever someone from your team needs to deploy a new virtual machine in Azure, we make sure they choose our golden image, and then we already know they're meeting our compliance standards and regulations from a technical perspective. Cool. And some of the examples of customizations that we have here are operating system hardening, deploying custom agents for for third-party software, and installing enterprise certificate authority CAs and root certificates. If you guys have any type of certificate or KPI infrastructure, you need to meet as well. Next slide, please, David. Cool, excellent. Now I want to talk through the kind of the end-to-end workflow of how you do the golden image publishing inside of Azure. So step one here, we have acquiring your base image. Now, I'm not going to go dive too deep into how you acquire this and what a base image is. But if you're choosing Linux-based operating systems, make sure you're choosing an Azure optimized image from your specified publisher. Step two here is this is what David's going to dive deep into, and the next couple of sections is using Packer to customize the image. And then we're going to look at the process of image tattooing, which I'll talk through in a couple of slides, and how we can track image version information, like the source and publish date. Next, we'll do some automated testing to validate the image. Again, David's going to talk through that. If the image fails any test, return to customization step for repairs. And then finally, steps 6 and 7, we're going to process the publish and upload the final image and make sure that the Azure Compute Gallery receives the image and it's available for our DevOps teams to finally deploy virtual machines or VM scale sets inside of Azure. Next slide, please, David. Cool. So I've mentioned, image tattooing a couple of times now, so I just want to talk through what this is. So image tattooing is a process of keeping track of all image version information at a VM or on a VM users. This information is available during troubleshooting. So for instance, here's an oversimplified example. If you have 3 stateless web servers and you notice one of them is behaving oddly and not processing requests correctly, what can you do? One thing you can quickly do and quickly check is the tattoo on that image to see if it's running the latest version of your image or if it's had an old publishing date. And if that is the issue, and that's one question you can answer quite quickly and fast, then you can make sure that you can just remediate that issue and redeploy that virtual machine because it's in a stateless set and make sure it's up to date with the latest image. Cool, so what can image tattoos contain? So they contain the original source of the image, such as the name and the version of the publisher. The next one is the operating system version string. Now, what you really want to do is make this the original operating system version string. So for instance, if you guys do an in-place upgrade, you can see that the existing operating system version string does not match the current operating system version string. So you can know that that virtual machines had an in-place upgrade completed on it, and then the version of the custom image and your publish date. But all this information and the type of information really depends on your organization's compliance level and their needs. So for tattooing on Windows virtual machines, you can set up a custom registry, is what we recommend, and add all the required information in this registry path as key value pairs. And that's quite specific, and we'll go through that later in the talk. And on Linux virtual machines, you want to edit the tattoo information as either environmental variables or in a file. Typically, we prefer a file in the etc folder, so it doesn't conflict with developer workflows and applications. And then the last bit here is, you can definitely absolutely use Azure policy to track all this tattooing data and report on it. But the key thing there is making sure, especially from the Windows virtual machine perspective, you set up the unique key value pairs to make sure you can track and report on all the Azure policy data. Cool. Next slide, please, David. Cool. Excellent. So next one is now you've done all this hard work, you've set up your image, you've done all the customizations, you're making sure it's meeting your technical requirements for your company. What's the next step we need to do? You absolutely need to make sure that you're restricting those images. So you don't want to allow your DevOps team to use Azure Marketplace virtual machines because they don't have your customizations. Only allow virtual machine deployments from images that you publish to the Compute Gallery. And this restriction is critical to ensuring your VM compliance. And again, after you've gone through all that hard work, you want to make sure that your team and your teams that are deploying things to Azure, are using the system machines and the golden images you've set up to making sure you're meeting those compliance standards. Cool. And the great news is you can use a custom policy in Azure policy to enforce this. So no one can spin up a virtual machine unless it's on your allowed list in Azure policy, which are the customized images that you guys have done that lives in the Compute Gallery. Next slide, please, David. Cool. And then the second kind of process we're going to talk about is really tracking the virtual machine compliance here. So as you can see here, the kind of the brains of the operation here is Azure policy. So what you want to do here is you're going to make sure that Azure policy assigns policy definitions to the virtual machines themselves, and it can also evaluate the VMs for compliance. And the second part of this is that Azure policy can then create dashboards for compliance. So you can actually see in real time, well, not real time, but you can actually see on the virtual machines, whenever it probes it, to see which virtual machines are in compliant or not compliant based on your virtual machine image tattooing data. Cool. And then just last piece on this slide is that we mentioned Azure policy. So Azure policy is the one that does the policy definitions, where you can enforce your organization standards and assess compliance at scale. The Azure policy dashboard displays results from the Azure policy evaluations, and this data can keep you informed about the compliance status of your resources. The second part of it is you can then use the Azure auto manage machine configuration for Azure policy, which provides a way to dynamically audit and assign configurations to machines through code. Cool. Next slide, please, David. Excellent. So I mentioned this concept before, so I just want to go through it here as well. So identifying pets and identifying cattle. So DevOps teams normally use an analogy called pets and cattle to define service models. To track a virtual machine's compliance, you first need to determine whether it's a pet or whether it's a cattle. So pets require significant attention and they're not easily dispensed. Recovering from a pet server requires investing in a considerable amount of time and financial resources. So an example here is a server that runs SAP, might be a pet. Another analogy for the Windows admins out there is I used to be a domain controller person a long time ago. So I'd definitely put a domain controller as a pet because it requires significant attention and it's not very easily just to rip out a domain controller and pop one back in. There's things like FSMO roles and other bits and pieces you need to consider before you can do that. Besides the software that runs on the server, other considerations can also be determined in the service model. If you have a low failure tolerance on production servers in real time, and anytime systems can also be called pets as well because of the high impact it has to production environments. Cool, so what are cattle servers? Cattle servers are part of identical group and they're replaced quite easily. So for example, an individual virtual machine inside a virtual machine scale set, we typically treat as cattle. So what that means is that if there is enough VMs in the set, your system keeps running, but you're not actually really concerned with the individual virtual machines or their names or their configurations because they're all identical. They all run as part of a set. Also, some testing environments and testing servers can also fit this bill because you might be automatically spinning them up, having some testing done and spinning them back down. Will definitely be part of a cattle server. Or if you're spinning up test environments or development environments with the same kind of pattern, they're definitely all cattle servers. But the main thing here, the difference between a pet and cattle is a pet requires significant attention and cattles are generally part of identical group that are easily spun up and spun down. Cool. Next slide, please, David. Cool, excellent. So compliance with pets and cattle. So it's really important to acknowledge that your environment might have only pets, it might have only cattle, or it might have a mixture of the two. So you need to make sure that you're assessing each application or platform on its own, with its own merits or pieces of that application to make sure you guys are identifying what virtual machines or virtual machine sets are pets and cattle. And how do you manage compliance in those different pieces? So with pet compliance can be more challenging to track than cattle compliance. Usually only DevOps teams or platform teams can track and maintain the compliance of pet environments and servers. And what you can do here is you can increase the visibility with Azure policy and the image tattooing. So make you guys easier to visualize and see and track compliance within the virtual machine. So what I was talking about before about the image tattooing, especially with pet servers, you might do in-place upgrades if it's a Windows machine. If you have the image tracking data, you can easily see if you've done an in-place upgrade on a Windows operating system, which is sometimes a little bit harder if you don't have that type of data or don't have that type of setup. So for cattle environments, normally what you do here is refreshing the VMs and rebuilding them from scratch is really quite easily and something you can do quite regularly. So as long as you guys have planned maintenance windows and you guys do monthly patching on a set of virtual machine scale sets, for instance, you guys can just roll through and upload that every month. And rebuild those virtual machines quite easily to making sure they're all up to date or meeting your company's compliance. Cool. Next slide, please, David. Cool. So improve visibility. So how do we do this? So generally, you should be using Azure policy to manage your control plane compliance activities is what we recommend. And what you can do with Azure policy, for instance, is you can track VM compliance that we've talked about. If you want to, you can install Azure agents on the operating system, but you can also do that in the customization process, which David's going to talk through. You'll be capturing diagnostic logs. And again, you're just going to improve the visibility of VM compliance. So you can track the compliance and improve visibility through a dashboard that you can give to your CISO or your risk manager or leaders in your team to make sure they can see the compliance in one nice dashboard. But the thing to use, again, is the Azure Auto Manage Machine Configuration feature for Azure Policy to auto the configurations that you make changes during the image customizations. So when drift occurs, the Azure Policy dashboards list the affected virtual machines as non-compliant, very clear, very easy to see. And this is using the image tattooing information to track when you see outdated images or operating systems. Cool. Next slide, please, David. Cool. A couple of quick tips here before we move on to the next section. Cool. So you definitely want to audit pet servers for each application and potentially for each piece of the application. So I'll give you an example. If you have a standard 3-tier web architecture, your web tier might be a VM scale set with stateless web servers. So they're definitely going to be, cattle servers that you can just spin up and spin down monthly with a rolling update in a planned maintenance window, and you can manage that quite easily. But you might have a stateful middle tier, and you're managing those virtual machines as cattle. And so that process is going to be very, very different to how you do with the pets in the stateless web server. Cool. And then for each DevOps team or platform team can track its own applications and pieces of their applications compliance through an Azure Policy dashboard. So definitely want to make this a team sport and really make sure that your DevOps teams and your platform teams are engaged in this process so they can clearly see which virtual machines are non-compliant and they can take the appropriate corrective actions. You can also assign Azure policies to a management group level or a subscription level, or you can assign them directly to a resource group to make sure that you guys are making sure the compliance is company-wide, environment-wide. And then again, last point here is IT risk managers and security officers. You definitely want them to get involved and in the process and making sure they can see the compliance dashboard through Azure Policy dashboard so they can have a look at and manage the company risk profile as a whole from a company perspective. Cool. Next slide, please, David. I think that's it for me. Over to you.
Thank you. And so what I want to do is take kind of the story that Michael's just put around where Azure fits and talk about it from Packer, and particularly now when you think about some of those constructs around how do you do that for a hybrid scenario. So we have a large VMware environment that we're still running in conjunction with our Azure. We have a multi-cloud environment where we're doing this across multiple cloud platforms. How do I do that image building across all of those different areas and building? And this is where Packer fits into that. So Packer is responsible for a lot of the AMI builds that are out there. And so Packer is a tool in itself. And what we have done is taken the HCP Packer, which is our HashiCorp cloud platform, and added a service over the top of that to help with some of those tracking and auditing and security components that Michael was talking about that are needed to be done in conjunction with still working with things like Azure Image Gallery. And then because obviously Packer is part of the HashiCorp family, there is a close integration with Terraform to allow for that as code approach to deploying those resources. So what we'll do is if we take a look at each of those individual elements and kind of go into what they're doing. So when we talk about Packer, Packer is that mechanism around building that image. So we take a configuration file, which is now written in HCL. So if you're familiar with Terraform, you'll be familiar with the stanza that you'll see when we look at the image builder file as part of the demo. And you take that structure and you start to define those resources that you want to build. And so within that construct, we're looking at, do we create a specific application mechanism? So as to Michael's point around, in our demo, we have a base Ubuntu image. From that, we actually install an application mechanism that has a dependency around Nginx. And so our base image or our golden image is that base. And then we have an iteration, which is our Nginx for that particular application. Within that construct, we can add in any of those dependencies. So that could be certificate dependencies. It could be workload dependencies. So it could be a file that actually allows for configuration mechanisms for within a web server, for example. It could be vendor tooling. So it could be you are embedding Azure Insights into this, so that as an image immediately comes up, it will immediately start reporting back and throwing data into Insights. It could be an integration into the Vault agent. So you could be embedding the Vault agent into this, so that when this service tool that you've created comes up, it can then actually make a remote call out to Vault and get a dynamic set of credentials. That dynamic credentials could then allow access for the application to gain access to a database, for example. And so that part of Packer and that image build is what the open source tool does, and is fundamentally building the image. And so the image is then stored into your repository wherever you choose that to be. We then take the Packer component, which is you own and store those images. So we're not interfering with that part. You built them, you get your golden image, you get your subsequent iterations of that into whatever form they want to be. What we do is, because of those elements that Michael was talking about, you then can see that there is a large amount of information around how do we know what this image is, where is it deployed, how do we track it, and how do we know what construct it is using, so that parent-child relationship, for example. And so in something such as the Log4j issue, where you had that as maybe a base element, as one of those base tools that everybody needed, you then need to understand, well, where is that deployed, and how can I actually how can I update that base element and make sure that all of those child elements are then updated as well. And so how do you track all that thing? And that's where HCP Packer comes into this, in that we are taking the metadata components and only storing the metadata elements around that to get that visibility. So you keep the image wherever you want in your repository. We take some information and we store that metadata to allow for auditing and control. And that's the element that you see in HCP Packer. And then using that information and that ability to recover that data source, we have an integration into Terraform. And so then we can then take and apply additional levels of logic into that Terraform workflow, so that we can actually, when we build or deploy an instance, we can actually get and see the right image and make sure we can validate it. We can start to get control and security into that to make sure that we're meeting with compliance. And so how these things come together is that you have the open source tool that is free for everybody to use and underlies a lot of the cloud image building out there. We add value with HCP Packer that is taking in that element around how do I actually then track and control. So a lot of the things that Michael was talking about in terms of all the best practices, integrate that in with my Azure platform. So we can still work with the Azure Image Gallery, for example, and then make sure that we can take an as code approach to deliver that, leveraging Terraform. And so in a practical perspective, this is where all those components come together. So in this, we can see that we have our golden image, and we have our iteration, or our cattle, for want of a better word. So we have that defined within our Packer files, and we'll have a look at what that looks like. We then push some of that information as we do that build through into HCP Packer. The image is then pushed and stored in that image repository, Azure Gallery being a great example of that. And within that construct, you could even have multiple images across different platforms. So that could be VMware images as well, right? We could store that image repository into a defined component. Then now we have that metadata component that we can track. We can run Terraform and start to actually take our build component. Now within the construct of HCP Packer, you'll see this when we look at it in the demo, there is the ability to query different channels. So basically a channel is a mechanism of saying, how do I understand where where that image or that base image is. So is that into dev? Is it into production? Is it into a particular work stream? And so as we're talking about, that the tooling and what is available, you can start to say, well, this is a dev channel. The dev channel has dev tools installed in it so that the developers can actually do more troubleshooting, and maybe permissions are a little bit wider so that they can actually self-serve in terms of understanding what's going on, whereas you wouldn't want those tools into production. So you can pick different channels across that. And from that, then we can take the right instance and actually run it through, do a validation check. So we use the run task component of Terraform Cloud. And so for those not familiar with run tasks, there is a plan and apply. In between that is the ability to take the information from the plan and push it out to validate that with a third party. We can do this for bridge crew, and we can do it for infra, just to name a few off the top of my head, to do different things. So whether that's security or cost optimization. In this case, what we're doing is we're actually validating that against the information we have from HTTP Packer, and we can actually then have a either a soft warning. So if there's something that we see as an alert, we can actually say, hey, we've detected this discrepancy, here's an error message, or we can actually enforce a mandatory stop saying, no, this isn't allowed. And so we can now apply that level of control actually in your work stream as you're trying to deploy this. So as organizations are moving to an as code approach, we can integrate that as code approach with the right image into that component, including then validating AMIs and other calls within the code set that may not have been past security, or as Michael pointed out, could be a call that someone's done from a marketplace. So we can validate that as well. So in the as code approach, we can actually take control of that. So if we think about what we need to actually create those golden images, there's a set of key things that we want to look at. So the first of those is visibility into that image cycle. So when we think about infrastructure, obviously some of that infrastructure can stand up for a long period of time. And if that's the case, how do we then validate and make sure that we have got the latest image? Because, to that point, if we built a domain server, probably no one's courageous enough to actually spin those up and down on a nightly basis. But we want to make sure that we're meeting our security and control components around that. So how do we get that visibility? The other thing being is how do we make sure that we're not provisioning with outdated images? So how do we make sure that our code that we've written, which we commit into VCS, and sometimes you've created a module or you create something and it has an image call in it that you think is great, and you haven't touched that for a while, but that image is then out of date. How do you keep control of those kind of constructs? And so this is where we have the ability to look into the code itself, and that integration between Packer and Terraform itself, you can get that validation in. So as part of that, we can do a life cycle block. We're not talking lifestyle shows here. A life cycle component, which is we can then actually go in and within the condition, a post condition. So as this image should be there, we can actually go and validate against that Packer image on a life cycle component. And then if that image is invalidated, we can actually then say, this image is out of date and we need to actually rebuild or take an action around that. So we're getting that continuous validation to actually take an action around what is built, and then actually get either an update or some sort of condition around being able to take an action against that. And obviously with invalidated or out of date images, we can actually get the ability to rebuild those as well. And so I spoke about that ability to have the channel. And so that channel gives you that automate control around which element we want to pull out. Within that, we have the iterations. And so what we can do within that is actually, if we invalidate one of those, you can actually again get a rollback component. And so what this means is that if we choose to invalidate a particular iteration, you can actually choose to roll it back within the channel, or roll it or back to a later version. So if, for example, you put a new version up, you started to spin up new images as part of that build, you see that you were running maybe a blue-green deployment, you see that those images are now failing or there was an issue, you could actually change and roll that back so that you're using the existing image and take that image out of the lifecycle and spin them down and drain them out. And so you do get this ability to control that or get control over your images as we run through that using the HashiCorp packer, so HCP packer. And then another important part, which was spoke to that last tip around how do you manage those long-lived, kind of pet servers. Within that, we also have the ability to revoke from a multi-level component. So as you have the parent-child relationship, so you have the ability to revoke within that relationship as well. And so let's take a look at some of those constructs, and hopefully some of the things that we've been talking about will make a lot more sense. So here you can see we have our images in Azure Gallery. So we have all of our images in here. So that's where Packer has built and created those images, and we've pushed them into that image gallery. We have our latest version within our channel. So you can see here that going to ask me to auth. I will auth again, but you can see there where that channel allowed us to have different component parts. So let me just log in, and we can see that again. Here we go. So this is, for those that haven't seen it, this is the interface or front door for HashiCorp Cloud Platform. In there, we have obviously access to all of our tools. We're just going to go and view our Packer registry. And in here, we have our images. This is, as again, that distinction between our base and our latest iteration, so in a different channel. So we can see that our parent is up to date, and we can see that our base image is up to date. We can see the platform that we're in, and we can see that those images are being controlled. Now remember, these aren't actually the images. This is the metadata that we're tracking. So when we dive into this, for example, you get that information. So within our channel here, we can actually dive into a version, the newest version here, and you can see that information that we are tracking. So this is obviously a lot of those elements that we were talking about, or Michael was talking about. You have your image construct, you have the OS type, you have the resource group where it is, you have a unique build image region, and you can see here that we can actually do things such as revoking that. So in our build history, you can see that we have versions 3 and 4. We could, for example, revoke this image, and that would mean that if anything happened to version 4, we wouldn't be able to roll it back. It is in the channel latest, and if we revoke this, as we'll probably do later, you'll see that this will then become the latest version that we will look at. Within our code, if we take a look at what's going on, these are our, where is the code that I want to look at? Not that one. Nginx. There we go. That's right. So this is our actual Nginx derivative. So in this, you can see, for those that are familiar with writing Terraform, if we look at just a standard Terraform file, you see that the stanza is incredibly familiar. So for the learning curve for actually understanding what's going on is relatively minimal. In this, we are obviously using Packer. We are taking some data and pushing that out as our, using it as our base image. So we're referencing our own base image. So in our channel, we have a development channel. We're creating a local timestamp, which creates that unique timestamp. We're sourcing from our Azure. So we've got that image source. We're taking, obviously, the data image name and the resource group. So we're pulling from that Azure gallery, and then we're using that and implementing the necessary configuration elements that we want to actually add into that. Plus, of course, add in some defined tags. And then as we build, we're pushing out to the registry the data elements that we want to track. So we've got our build and our owner, department, and constructs. We are also running and defining a provisioner. That provisioner is then actually running within the construct of the build. So what I will do is I will kick off well, you can see a build here. So the reason I won't kick it off is because it takes about 20 minutes. So you can see that by running packer build, what it will do is actually output through the build process. So we are authenticating using a service principal. So basically within HCP, we're defining our credentials, which is based around a service principal or IAM role, and then you export that and put it into an environment variable to allow Packer to actually communicate with it. As we run through, you can see it's starting to actually build and customize that image, and then runs that provisioner into that image to customize those the description elements that we want to, and to push the replication components. We share it into the image gallery, and then we have basically finish off those components. So now within our construct, this is where we have that version 4. In a use case, and how do I use this, we can now actually reference this within as a data source. So within our Terraform code, we just reference a HCP packer. So we pull the information out from where we want, so our channel being latest, and then use that data source reference within our image. Where's our virtual image? Image. No, I've gone past it. Virtual machine. There we go. So our source image is then referenced as that to tell the, our build where it's actually happening. And so if we kick this off, you can see that. Well, you can see that I've shortcutted the Terraform commands because I'm lazy. But also, this is building out a Terraform apply. So this is a remote run. So we're running this against Terraform Cloud, which I'll show you where this parallel runs. But you can see that within this construct, we now have our data refreshing. So we're checking that source to see if it's valid. And if it's actually still hasn't been revoked. If it passes that, it will pass that data information into as our source and allow our build to then stand up. There we go. So you can see that we're now doing the post plans, because within our Terraform Cloud, we've actually invoked the HCP Packer check or run task. So you can see here it has passed. So if we look at where that is in Terraform Cloud, go into a run, go into settings, we go into run tasks. You can see here we actually have our HCP Packer run task. It's doing it on a post plan, and you can see that enforcement level that we have defined. And so with that being defined on that run, if, for example, we went back and invalidated this or revoked this, because I can, let's revoke this. You see that this becomes revoked. So now we have, you can see that this will be updated, and that will become the latest version, will become version 3. If we then run our Terraform plan again, it would still build and still pass because our channel has been revoked. It's taken us its time, and it would use the latest version of that. So it would still pass because it would use the version version 3, which is that channel rollback component. So, and I just show you that there's separate channels. So there we have that latest channel. You can see the latest channel is actually showing version 3, which was built just to prove, has a build date of the 9th. So, so you can see how you can instantly get that rollback. And so there we go. It's now become the latest. So again, integrating that control into your workflow, allowing for you to track all of this information and keep control of that image while still leveraging the Azure platform for image control and elements like that. So with that, I am going to hand it back into, if you want to get started, there is obviously an Azure free trial. We are on Marketplace, and obviously there are some links there. The slides will be shared as there's a question. So the slides will be shared with everybody is registered. So you will get a copy of these, so you can use these links and know where these elements are. If you want to look at how this fits into part of a zero trust story and how image compliance becomes an important part of delivering that overall zero trust as integrating with the Azure platform, please go and download this book. It's a joint ebook that we have created with Microsoft. Has some really good value into it, and I will open it up for Q&A and see if there are any questions in there. There was one, I don't know, did you answer that one, Michael, around the...
Yeah, I answered Oren's question already.
Yeah, do you just want to read it out? Because obviously there's...
Sure thing. So Oren's question was, are there any templates for Azure policy available to quickly start enforcing allowed images? And I replied with a link. Absolutely, there are some Azure policy samples that you get up and running pretty quickly with that ask.
And there's also on the HashiCorp developer site, there is some great AWS and Packer examples as well. So there's some great examples there. We have just today released the new version of the Packer API, which changes and integrates a whole bunch of new features and functions as well. So if you are familiar with Packer or you're looking to build, go and look at that the new release. It's also changing the way that they've built in with the SDK kit. So it's a better integration and allows for an even deeper integration between the two platforms. If there's any other questions, please feel free to put them into the Q&A. I haven't checked the chat. I should do to see if there are any in there. Nope. So if there aren't any other questions, or if that is it, then we thank you for joining us, and I do appreciate you spending the time with us, and hopefully it was you learned something or there was something of interest there. Please feel free to reach out to any of us on this call if you want to learn more, and we get more than happy to help you. So I'll give you a few minutes unless if there's any other questions. If not, we will close this out and give you some time back. Oh, can't see anything. In which case, thank you all, and I will give you some time back. Thanks to our presenters. Thanks, Michael. Always a pleasure.
Cheers.
See ya.